So we're working in OpenStax Statistics Chapter 7, and we're talking about the central limit theorem for sums. So this is actually a worked out example. You can always reference OpenStax at their website for free. You can look in the description of this video for a link. And you can always get a copy of this Excel workbook totally for free. Go to divideandconquermath.com and go to the OpenStax Statistics section. Okay, so we have an unknown population has a mean of 90 and a standard deviation of 15, and a sample size of 80 is drawn randomly from the population. So find the probability that the sum of 80 values is more than 7,500. Okay, so notice how this question is worded a little differently from what we've seen in the previous tabs, because we're talking about find the probability of that the sum of the 80 values. So we know how to work with our given data. So we've got our 90, an n of 80, and a sigma of 15. And we've talked about our distribution of means. So the distribution of means shares the same mean from before. And then we've talked about with our sigma, you take your sigma from your data divided by the square root of n. So we've talked about getting into our distribution of means. But now really what we're moving into is more of like a distribution of sums, which really just requires a few tweaks to the data that we're using and that we're making our probability predictions off of. So I have here a little cheat sheet reference. So your mean is going to be whatever your n times your whatever your data's mean was. So in this case, so I'm going to have 80 times 90. So that's the mean that I'm going to use for the sums. And then your standard deviation is going to be found still using your given data, and you take your n times your square root of you take your sigma times your square root of n. So that's all listed out here. Okay, so this is now a different type of distribution we can kind of think of. And so then when I'm asking what is the probability that the sum of 80 values is greater than 7,500, well, it's the exact same idea from the previous tabs, except now we're using the mean of the sums and the standard deviation of the sums. So I am omitting the picture in this case because I'm hoping you can kind of visualize. So this will be calculating to the right of 7,500. So I put in 7,500. I use this mean from the sums and this mean from the standard deviation, and then I can calculate my probability. So there you go. So that's the idea with these types of problems. And then we have that the sum, or find the sum that is 1.5 standard deviations above the mean of the sums. So in this case then, so we're just going to use this information that we calculated up here. So I take my mean, 7,200, and then 1.5 times the standard deviation, and bada bing, bada boom, there you go.